So in this video, we're going to look at stopping distances. So first of all, what is the stopping distance? The stopping distance of a car is defined as the total distance travelled during the time it takes for a car to stop in response to some emergency. It can be written as an equation as well, as we can see on the screen, which is stopping distance is equal to thinking distance plus braking distance, where thinking distance is equal to the distance travelled in the time it takes the driver to react, otherwise known as the reaction time in meters, and braking distance is the distance travelled under the braking force in meters. So the stopping distance is the sum of the thinking distance and braking distance in meters. So let's have a look at this example here. At a speed of 20 meters per second, a particular vehicle had a stopping distance of 40 meters. The car travelled 14 meters whilst the driver was reacting to the incident in front of him. What was the braking distance? Is it A, 54 meters, B, 34 meters, C, 26 meters, or D, 6 meters? So pause the video here, have a little go, and we'll go through the solution on the next slide. So the answer to this example was C, 26 meters, and we'll go through now how we can get to this solution. So the first step we want to do is we want to identify the different variables. So as we saw in the question, the stopping distance is 40 meters, and we were also told that the car travelled 14 meters while the driver was reacting. This is a thinking distance. The second step is we want to rearrange the formula for stopping distance to get braking distance as a subject instead. So we'll need to subtract across thinking distance from both sides, leaving us with braking distance equals stopping distance minus thinking distance. And finally, we'll calculate the correct braking distance by using this formula. So stopping distance, which was 40 meters, minus thinking distance, which was 14 meters, is going to leave us with 26 meters. And now I'll have a look at reaction time. So reaction time is defined as a measure of how much time passes between seeing something and reacting to it. The human's reaction time for someone who is alert, for example, someone waiting to react to something happening, like an athlete waiting for the start of a race, is usually in the range of 0.2 to 0.9 seconds. We can measure a person's reaction time by using a ruler. Person A holds a ruler vertically, such that the bottom end of the ruler hovers over the top of the hand of person B. Person A should release the ruler unexpectedly, and as soon as person B sees the ruler move, they should close their hand, catching it. The ruler is marked at the point where it was caught by person B, and this gives a measurement of the distance the ruler fell. The greater the distance, the longer the reaction time. And we'll just have a little look at the factors affecting stopping distance. So the main factor affecting the braking distance of a car is its speed. The greater the speed, the greater the braking distance. There are also some additional factors which affect the braking distance, such as the vehicle condition, for example, worn tyres and poor brakes. This will affect how smoothly and quickly the car can brake. We also have the road condition. So if there's wet or icy roads, it's harder to decelerate, and that's because there's less friction on the road for the wheels to slow down on, so it's much smoother for them to run on. We also have the vehicle mass to bear in mind. So if we have a heavier vehicle, such as a lorry, it would take much longer to stop. Looking at thinking distance, this distance is mainly affected by tiredness, distractions such as being on your mobile phone or adjusting the music while driving, and also intoxication, so consumption of alcohol or drugs, as these will all slow down your reaction time. Hope that helped though. If you have any questions at all, please comment below and we'll do our best to help.